Now that we've talked about the structure and functionality of the Java phaser, let's take a look at some of its key methods. As you'll see, there's a lot more methods that are in the phaser compared to what's in countdown latch or cyclic barrier. And these methods, they're not only more of them, but they're also intended to be used in a much broader range of use cases. Fortunately, a lot of these methods are very rarely used in practice, which is good because it would be daunting if you had to learn 24 methods to use this class. You can stick with a relatively small number of methods and get most things done. So there's a couple of constructors as usual, and they can be used to initialize the phase number to 0 to start with. One of the constructors will specify the number of parties needed to advance to the next phase. And this number of parties dictates when the phaser can advance to the next phase. So much like the cyclic barrier, you start out with a party count if you choose, and that will be used to dictate when you've reached that count, then you can go to the next phase. Although, as we'll see, the party count is a dynamic property. This constructor that takes the initial parties count actually is optional because you can always register parties later using some other methods we're going to talk about momentarily. With Java phaser, the number of parties don't need to match the number of threads, whereas with the cyclic barrier, they needed to match. So this gives you some additional flexibility and also some additional complexity. This constructor doesn't actually specify any parties initially, so they all have to be added dynamically. So any phaser that's created with the default constructor will need to be registered by other threads before you can use this thing in some sensible way. We then have a bunch of other methods. There's 5 or 6 methods that are important here. And these methods are used to enable parties or threads to register, synchronize, and terminate the phaser and the phases that it's working through. A couple of methods are used to add unarrived parties to the phaser. So this is basically kind of like incrementing the count of parties dynamically. And there's 2 methods. One's called register, and that just adds 1 party. And another one's called bulk register, where you can give it a number of parties. I don't know why they didn't just have register that took no parameters and register that took parameters, or a parameter, but that's the way they decided to define the method names. And again, ultimately, the number of registered parties will indicate or dictate to the phaser when it can go to the next phase. There's also a slew of methods that are used to arrive and await advance. And these are a little confusing when you first see them. And they're split up this way for various reasons. Having multiple methods to do this stuff provides flexibility with respect to arriving and waiting to advance. And you'll see there's a couple of different variants here. The method called arrive says, I'm here, I've come here, but it doesn't actually block until the other parties arrive. So it just says, I showed up, but I'm not going to wait around. It's like having a worker show up and say, I'm here to do framing. The rest of my crew isn't here yet, but I'm going to start working, but I'm going to count myself as having arrived. It returns the current phase number, or it returns a negative value if the phaser has already been terminated. So you can know that there's no sense in doing anything because you're done. Luckily, this method is very rarely used in practice, so you don't use arrive a whole lot. There's another method called await advance, which blocks until the phase of this phaser advances from the given phase value. So you give it a value, and then it will wait until it has reached that, or it's moved away from that value. If the current phase doesn't equal the given phase, it'll return immediately. This method is also very rarely used in practice. There's a final method, which of course is used, which is called arrive and await advance. And what this does is it indicates I'm here, and now I'm going to wait for the rest of my parties to show up. So again, think about like going to a restaurant where you could arrive and go sit at the table. And this is more like the arrive and wait in the waiting room for the rest of your party to show up before you all get seated. This is essentially the same as using the await advance method, calling arrive to provide it with the phase number. So arrive and await advance is like calling await advance with arrive as the parameter. This is the very most common method used, and it's quite similar to the await method on Java cyclic barrier. So it says, hey, everybody, I'm here, but I'm going to wait for my other parties to show up before I advance. There's also another method, believe it or not, called arrive and deregister. And this arrives at the phaser and deregisters without waiting for anything else to arrive. So it basically says, I'm here, and I'm not going to wait for anybody else, but just let you know I'm here. And this reduces the number of parties required to advance in future phases. So I guess it's kind of like the person who's the foreman or the foreperson at a work site shows up and says, okay, I'm here, just letting you know that the day started. I've checked a few things out, and now I'm gone. Don't wait for me to be here any further. This particular method is often used by the party that controls the initialization of the phaser. So what we typically do is we want everybody to wait until the main controller has arrived, and then they can start, and that guy goes away and is not considered any further in the phasing and the cycles. There is yet another method. This is a hook method, very similar to the barrier action we talked about with cyclic barrier. And it's used to perform an action when the advance of a phase is pending. And you can see that it's given a default value, and its method is invoked upon the arrival of the party that's advancing the phaser. So pretty much when whoever the last one is going to do that. Much like with the barrier action we talked about for cyclic barrier, all the other parties or threads are considered dormant, in other words, not running, when this particular hook method runs. And as I mentioned, this method is very similar to the barrier action on a Java cyclic barrier. You can also indicate that the phaser should terminate by returning a true Boolean value. And we'll take a look and see how that works. You can see here that by default, if the number of registered parties equals 0, in other words, nobody's registered anymore, then go ahead and terminate the phaser because we're done. So that's what this comment's saying, that the default implementation of the onAdvance hook method will terminate the phaser if there's no more registered parties, if they've all deregistered at this point. So that's the end of the overview of the many methods in Java phaser. Don't get daunted by this. As it turns out, in practice, there's some pretty straightforward use cases, which we're going to look at in a moment, that cover a lot of the situations where you need to use a phaser. So the fact that there's so many methods doesn't really cause a problem in practice. However, if you need the features and the functionality provided by phaser, then you'll have to dig a little deeper and understand how these methods work.